So this is butene. We draw, first of all we started with ene. Okay, so we have to start with the ene. Ene mean carbon to carbon double covalent bond. Then but stand for the 4 carbon atoms. So if it is carbon 1, then 2, 3 and 4. You must have to remember, always start numbering from the terminal where double bond is closer. Okay, so always start numbering the long chain of the carbon atoms in the parent chain where the double bond is closer to the terminal. So now completing all the bonds, and as you know, we discussed, this is a hydrocarbon. But is completed, ene is completed, so all the other bonds will be completed by placing hydrogen atoms. So this is the displayed formula. Now to convert this formula into the structural formula, we have to write each carbon atom separately, like this: CH2, then CH for this carbon atom, and CH2 for this carbon atom, and CH3 finally for this carbon atom. As structural formula is writing each carbon atom separately along with its directly bonded atoms. Okay, so time to write the molecular formula. It will be C4H8, and the simplified form of this formula will be CH2. So as I discussed, it is compulsory, it is mandatory to mention the position of the double covalent bond if we have 4 or more carbon atom in the molecule. Okay, so and by default, if there is no number, then by default it stands for 1. So either it is written as butene, or it may be written as but1ene. So both are correct. This 1 indicates the position of the carbon to carbon double bond. This is the position of carbon to carbon double covalent bond. So we must have to mention the position. If no position is not mentioned, it means the double bond must be starting at carbon number 1. So we have to draw another one, like I first draw the structure, like you can say this type of the structure. Can you name this structure? Pause the video and try to answer it. If you successfully name this structure, it means you understand it properly. But the difference is in between this structure and this one is only the position of the carbon to carbon double bond. You can see this structure contains the 4 carbon atoms, but the only difference, the double bond is in the middle of the chain. So we must have to start numbering from either side, as the double bond is closer, equal distance from each side. Like if we start numbering from the right sided carbon atom, so this will be carbon 1 and the double bond will start at carbon number 2. And if we start numbering from the left side of the carbon atom, then the numbering 1, 2, so it will be carbon number 2 again. So the name of this molecule will be but. We have to mention the position 2 and ene. So it means that we have total 4 carbon atoms, in which at carbon number 2 there is a double covalent bond. And to convert this structure into the molecular formula, what we have to say, it will be to the structural formula, it is CH3, then CH, then CH, and finally CH3. To convert it into the molecular formula, we will get C4H8, and the empirical formula will be CH2. Now remember and try to understand the phenomena which is present in between these two molecules. You can see clearly these two molecules have the same molecular formula, that is C4H8 here, and the butane also has the same molecular formula, C4H8. What it means? It means these two molecules have same molecular formula, but the arrangement of the atoms is different. You can see the arrangement of the atom is different in but1ene and is different in but2ene, but both have same molecular formulas. So this type or these type of the molecules are considered as isomers. These type of the molecules are termed as isomers. So inshallah in later videos we will discuss about the isomers. So you have to keep that in mind. If any type of the molecule which have the same molecular formula, but the arrangement of the atom is different in the form of displaced formula or in the form of the structural formula, then we consider molecules as isomers of each other. Now we have to consider another molecule in which we have to discuss the branching, and we discussed in our first video of the organic chemistry that if we found more than 2 terminals in the molecule, then we have to say the molecule is branched chain hydrocarbon or the derivative of the hydrocarbon. For example, I have to draw a structure like C here, and I draw one carbon atom to this terminal and another one to this terminal, and then preferably I draw these hydrogens. Now you can see this is a molecule in which we have more than 2 terminals. Like this is the first terminal, then this will be the second, and this will be the third. Or this is the first terminal, this will be the second, and this will be the third. But in very short, this molecule has more than 2 terminals, and it clarifies this molecule is a branched chain molecule. So first thing is first, you first have to choose the long chain of the carbon atoms, and remember that in mind, that long chain must contain carbon to carbon double covalent bond. That must contain carbon to carbon double covalent bond. So by selecting the long chain of the carbon atom, you must have to remember it must contain carbon to carbon double covalent bond. So here this is the carbon to carbon long chain which contains 3 carbon atoms, So then this will be the branch, and you know that if one carbon is present at the branch, we name it as methyl. Now we have to number the long chain, but start numbering from the terminal where carbon to carbon double bond is closer. So this will be the preferable numbering, like this will be the carbon 1, this will be carbon 2, and this will be carbon 3. Okay, now as you know, first of all we have to mention the position of the branch, and you know in this structure the branch is present at carbon number 2. So we have to mention the position 2, indicating that branch is at carbon number 2. And the name of the branch is methyl, as it contains only one carbon atom. So it will be 2-methyl. Then in the long chain of the carbon atom we have 3 carbon atoms, prop. But as the double bond is present and we have only 3 carbon atoms, so it is not necessary to mention the position of the double bond, as in a molecule less than 4 carbon atoms, no need to mention the position of the carbon to carbon double bond, as it must be at carbon number 1. So it will be propene. So the name will be 2-methyl propene. Now again, what will be the structural formula? This is the displayed, and now we are proceeding for the structural formula. So the structural formula will be CH2, then C, and we have CH3 whole twice. Remember, this carbon has CH3 group to the both side. That is why we may write it as CH2C and having 2 methyl group connecting to carbon number 2. Or we may write this structural formula as CH2C, we have to write the bracket CH3, and then outside the bracket we again have to write the CH3. It shows that this carbon is connected to CH3 group to one side, and to the other side there is another CH3 group. So both format are acceptable, and you have to notice, so that if in the exam you found any type of the structural formula, so then you can recognize it clearly and easily. Now proceeding towards the molecular formula. For molecular formula we have to remember, we choose or we have to write each different type of the carbon atom collectively in total. So we have 2 different type of the atoms, hydrogen and carbon. We have total 4 hydrocarbon atoms in this molecule, and we have total 8 hydrogen atoms in this molecule. So convert it into the empirical formula. We have to write it as CH2. Again, one thing common with the previous 2 molecules, the one was but1ene or butene, the other one but2ene, and now it is 2-methyl propene. What is common? That all of the 3 molecules have same molecular formula. You can see this is C4H8, the but2ene also has C4H8, and but1ene also has the same molecular formula, that is C4H8. But the displayed formula and the structural formula are different in all of the 3 cases. So again, I have to repeat, this type of the phenomena, when the molecules have same molecular formula but the arrangement of the atom is different, is called as isomers. Okay, and again I am repeating, we will discuss the isomers in detail in new video. So now almost we are finished with the structure and the namings of the alkenes. You can practice it properly so that you can understand it properly. Okay, but keep that in mind, whenever you are provided with any alkene, you must have to start with ene, and by that inshallah you will draw the molecular structure, you will draw the structure, the structural formula displayed, molecular formula very easily. Now proceeding towards the next format, that if you are provided with the name and you have to draw the structural or the displayed formula, then what we have to do, like I'm going to write pentene, or sorry, we are starting with the structure first and then we have to name it. Like we can say this is the structure, I'm going to write it for you, and you have to pause the video and try to name this structure. If you correctly name it, mean you are done with that. Okay, so now you have to pause the video and name this structure. Now we have to answer it. As you, I think, worked it out, it is pentene. Or some of the student, if they find out it is pent-1-ene, this is also correct, as we have 1, 2, 3, 4 and 5 carbon atoms, and the carbon to carbon double bond is position 1. That is why it is called as pent-1-ene, as by default if there is no numbering, the double bond must be present at carbon number 1. Got it? So the structural formula will be, again you have to pause the video and try by your own self. Okay, if you complete the structural formula like this, so it's correct and you successfully learn how to write the structural formula. And to write the molecular formula, again pause the video and write down the molecular formula. If you correctly mention that, you are right and you are doing good job. And the empirical formula will be CH2. Now I have to mention one other common thing that you may notice, that so many alkenes we practiced, but in all of the alkenes the empirical formula is the same. Like in pent-1-ene we have CH2 by the end as empirical formula. In butane we have the molecular formula, empirical formula CH2. In butane we have the same empirical formula. In 2-methylpropene we also have the same empirical formula. And previously we discussed the ethene, which have the same empirical formula, the propene, which have the same empirical formula. Now in exam it can be asked why alkenes have same empirical formula. What should be asked? The question: why all alkenes have same empirical formula? So what should be the answer? Why all alkenes have same empirical formula? So the answer is, as the ratio of carbon to hydrogen in all alkenes is 1:2. That is why all alkenes have same empirical formula. And here you must have to remember the general formula, of alkenes. it is CnH2n, and this also indicates that we have 1n and then 2n. Clear? So as the ratio of the carbon to hydrogen in the general formula is also same, that is why all alkenes have the same empirical formula, that is 1:2. Carbon, always hydrogens are double the carbon atoms in that molecule. Okay, so hopefully you understand it. I quickly recap what we learned in this video. We start learning about the alkenes, in which we discussed that alk means number of the carbon atoms and ene stand for carbon to carbon double covalent bond. And then I advise all of you to start with the ene if you confirm that the given molecule is belong to alkene homologous series. If the given molecule belongs to the alkene homologous series, we must have to start naming, or must have to start drawing the structure starting with ene. So this is my advice. If you follow, then inshallah you will draw all of the given structures successfully and very easily. So this is all about the alkenes. We discussed it, and inshallah in the upcoming video we will discuss the naming and structure of some alcohols and other organic molecules, inshallah. Hopefully you liked. If you have any comment, if you have any reservation, any problems, any queries, you can ask in the comment section. Thank you. Take care. Allah Hafiz.